Hey everyone, here's our math problem for today. This is a hard algebra problem. Find the real solutions to the system of equations. We have 1 over x plus 1 over y equals 9 as our first equation. And for the second equation, we have the quantity 1 over the cube root of x plus 1 over the cube root of y times the quantity 1 plus 1 over the cube root of x times the quantity 1 plus 1 over the cube root of y equals 18. You can pause the video and see if you can solve this challenging algebra problem. Now, let's solve this problem together. Notice here that we have a cube root of x and cube root of y. So in order to eliminate getting the cube root, we can reverse the process by raising to exponent 3. And so, let's begin with an identity, the cube of a trinomial. In here, we are going to let a be equal to 1 over the cube root of x, b would be 1 over the cube root of y, and c would be 1. So we have this assignment here. Now, following this identity, we can now expand this cube of a trinomial this way. The cube of 1 over the cube root of x is 1 over x. The cube of 1 over the cube root of y is 1 over y. And of course, the cube of 1 is 1. Then we copy this 3 and copy all the rest, where a is equal to 1 over the cube root of x and b is 1 over the cube root of y. Now, concentrate on this part. What do you notice here? 1 over x plus 1 over y. That is exactly this value. Therefore, we can now replace this with 9, and we now have this result. 1 over x plus 1 over y equals 9. And copy all the rest, then simplify. Another thing that we can notice is from here all the way here, that is just the same as this part here. And therefore, we can replace this with 18. And therefore, the right side are all now integers. So we have 9 plus 1 plus 3 times 18. Because this 1 plus x plus 1 over y becomes 9 based on the first equation. And this 3 factors in color yellow is equal to 18 based on the second equation. So let's simplify this further. 9 plus 1 is 10 plus 3 times 18. This gives us 64. And we take the cube root of both sides to get 1 over the cube root of x plus 1 over the cube root of y plus 1 equals the cube root of 64, which is 4. Then, let's simplify further by subtracting both sides by 1 to arrive at 1 over the cube root of x plus 1 over the cube root of y equals 3. We subtract 1 from both sides. Now, take this as our equation number 3 and take this first equation here and solve this equation 1 and equation 3 simultaneously, and we now have this simultaneous system. This is the system of equation that I posted to our page yesterday. I have seen different answers from our community members, and I would like to acknowledge their different answers. The first one is given to us by Professor Ngok Lihoy, and here is his solution. I'm going to discuss the solution later on. His final result is x equals 1, y equals 1 over 8. But since this equation is symmetric, we can interchange x and y and still we have the same equation and still we have the same result. So we can also interchange 1 and 1 over 8 for the value of x and y. So x could be 1, y is 1 over 8, or x equals 1 over 8 and y is equal to 1. Then we also receive another good answer from Mom Patricia, and here is her comment. And she arrived at the same answer, x equals 1 over 8, y equals 1, or vice versa. Then, we also got answer from Kenneth Ishaku. Just correct me if I mispronounce your name. And he arrived at the same result also. Then we also have this answer from Sin Chandi, and he arrives at the same result, 1 over 8 and 1. And also, we received this answer from my favorite doctor, Dr. Louis Lobalzamo. And he got the same result, 1 over 8 or 1 over 8, 1. Also, here is the answer from Sir Alejo Alemania, and also the same result. He has an interesting answer here, different from the other methods. And here is also the answer from Chris Travis Austria, and his answer also are x equals 1, y equals 1 over 8, and he used trial and error. Estimation is a very important skill in solving math problems as well. And finally, we have this answer from Isam Elshar. He always gave me very good answers. Thanks a lot for your answers, Isam or Esam. And also he got x equals 1 and y equals 1 over 8. So we have different methods from some of our community members. You can check our post related to this topic from our page. But I would like to discuss one of those methods that they presented. So this is the method used by Ngoc Lihoy. So this is how this is answered. We let u be equal to 1 over cube root of x, which is this part here. So we let that to be u, and v be equal to 1 over the cube root of y. The reason is we are using a variable substitution to make our computation easier. So if this is u and this is v, then 1 over x could be arrived at by getting the cube of u. And therefore, this 1 over x is simply u cubed. This 1 over y is v cubed, and we copy the right side. And the second equation is u plus v equals 3. Notice that if you raise 1 over the cube root of x to the third power, you will get this 1 over x. That's why you have here u and you have here u cubed. We are going to solve this system of equation simultaneously. So, what are we going to do? Let's recall an identity to expand u cubed plus v cubed, and that is the quantity u plus v times the quantity u squared minus uv plus v squared. So, this part here is now expanded this way. Then, we raise the second equation to the second power, and we simplify. The square of the binomial u plus b is u squared plus 2uv plus v squared, and that is equal to 9. Then, let's continue. Notice that u plus v, this part here, is equal to 3. So we can replace this with 3, and we divide both sides by 3. This 9 becomes 9 divided by 3, or 3. So the right side here is 3. We now cancel out u plus v. And what's left is this second factor. We copied the second equation. Then, let's recall this part, and let's erase everything except the last two equations, because we are going to do this, and we are going to solve this simultaneously. Let's subtract these two equations. So u squared minus u squared is 0, 2uv minus negative ub is positive 3uv, and 9 minus 3 equals 6, v squared minus v squared is 0. Then dividing both sides by 3, we get uv equals 2. This is what we need. The product of u and v is 2, and the sum of u plus v is 3. So, let's put now these two results here. Again, we have here a system of equations. Now, according to the solution presented to us by Sir Ngoc Lihoy, let's recall that when we have a quadratic equation, we can write this as x squared plus bx plus c equals 0. But since we have the variable x here and the variable y here, I just use any other variable, let's say r, to differentiate it from this variable. So we have here a quadratic equation. If the roots of this quadratic equation are u and v, then we can rewrite that quadratic equation as the quantity r minus u times r minus v equals 0, because the roots are u and v. r sub 1 equals 0, r sub 2 equals v. Then, let's remember that when we have a quadratic equation with a equals 1, here, the coefficient of the squared term is 1, the sum of the roots would be the negative of the coefficient of r from the Vieta's formula. And the product of the roots would be this c. If the coefficients of this r squared is a, then this would be negative b over a and c over a. But we have here a coefficient of 1. Now, what does this mean? The sum of the roots is b, and the product of the root is c. If those two roots are u and v, we know that the sum of u plus v is equal to 3, and the product of u and v is equal to 2. So this negative b must be this negative 3, and this c must be this 2. And so we can now rewrite this r squared plus br plus c equals 0 as r squared minus 3r plus 2 equals 0. Because we have here the negative of b, and we have here c. And so, this is factorable. The factors are r minus 2 and r minus 1. That is equal to 0. And notice now that this part here and this part here are exactly the same form. r minus u times r minus v, r minus 2 times r minus 1. So they are exactly the same. Both are equal to 0. So from here, it follows that this u is equal to this 2, and this v is equal to this 1. So we now have this two roots. R sub 1 equals 2 and R sub 2 equals 1. Where R sub 1 is u, which is our first root, and R sub 2 equals v, which is our second root. Now, it doesn't matter whether we write first -1, -2, and therefore u becomes 1 or v equals 2. It doesn't matter because multiplication is commutative. And this has some implication in our final answer later. So at this point, we have just computed that u, which is this part, is equal to 2, and v, which is this variable, that is equal to 1. And so we can now substitute these results to this u and this v, and this is now what we have. This is our original equation that was reduced to this system of equations with values now of u equals 2 and v equals 1. So substituting these values to u and v, this is now what we have. U equals 2 equals 1 over the cube root of x. Then we raise both sides to the third power, and we solve for x to get x equals 1 over 8. This is the first value for x, which is this x, which is this x, which is this x. Next is v equals 1. So if v equals 1, we now have 1 equals 1 over the cube root of y, and raise both sides to the third to arrive at 1 equals 1 over y, and solving for y, y is equal to 1. And so this is our second value, which is the value of y, of this y, and of this y. But we said that this u could also be 1 and v is the 2. And when that happens, then we also have this other possible pair, x equals 1 and y is equal to 1 over 8. And to check whether our answer is correct or not, we now substitute x equals 1 over 8 and y equals 1. And here's the computation from Desmos online graphing calculator. So 1 plus 1 over 8 plus 1 over 1, which is this first equation that is indeed equal to 9. And this part here is indeed equal to 18. Then, if x is 1 and y is 1 over 8, we do the same checking and using, again, the same graphing calculator. We also arrive at a correct equation for equation 1 and another correct equation for equation 2. And so we are confident that our answer is correct. And we are testing another series here in our page. We know that there's so much talent and so much creativity among our community followers and members. And therefore, on some occasions, I plan to post a problem. And then in the next video, I'm going to summarize the different points of view, get samples of the different methods of solving that problem, and acknowledge those who provided the answer. That way, we'll be forming a strong community, and we acknowledge that we do not have the monopoly of the mathematical knowledge. So thank you very much, and we hope to see you again in our next video. Bye for now.